Hello and welcome to the ADS and ADV webinar, all about visualization and data. We're very pleased to be collaborating with Netherlands Data Visualization Meetup group. And we will have two excellent talks from Evelyn and Emma coming up. I want to tell you about Amsterdam Data Science. So we are a network organization that aims to connect academia, industry, and society in the fields of data science and AI. And we really focus on the Amsterdam area. As I said, we try to collaborate with industry and academia, and this is one of the platforms we use to bring people together and share knowledge. And I will pass you over to Anastab, who will tell you a little bit about Netherlands Data Visualization Group.
Hello, everyone. Welcome to this fantastic webinar jointly organized by Amsterdam Data Science and Netherlands Data Visualization Meetup Group. So we are much younger than Amsterdam Data Science with a strong focus on anything that is related to data visualization. We started towards the end of last year, towards the end of, I would say, autumn last year. And this is our first webinar. We have had panelists and guest speakers who work for big brands, small brands, but with an extremely core focus on what is data visualization and the various pitfalls or the various challenges that people across all streams of data science, be they data scientists, be they data analysts, or even other people working with data face when it comes to presenting data to a corporate audience, to an academic audience, to any kind of business audience or even non-business audience. So the communication related to data, that is what we focus on. And today we have some of the guest speakers, two of them who have done extensive research work, both in terms of academic research work and both in terms of the sort of business-oriented, but also the other kinds of research that happen. So we have two panelists today, one here in Amsterdam and one in Germany, in Munich. So I'll start, because we're in Amsterdam, I'll start with Emma, who works at the Digital Society School of Amsterdam at the University of Amsterdam as a research specialist. She has focused for a long time on various aspects of data science, but in particular, her focus has also been on fairness in data. The other speaker we have today is Evelyn Münster. She is based in Munich, and she has a background in media art and a strong experience in software development and data analytics. Her work is also often connected to explaining data visualization to corporate users. So as we see today, our panelists cover both sides of the field, which is one is the academic side, the deep research, and also research, particularly oriented towards corporate fields. I'll now pass on the speaking time to our two panelists. I'll also quickly introduce you to Julia, who is operating as the manager for Amsterdam Data Science as well. We have been talking on and on to organize this. So yes, before we start speaking, a big thank you to everyone here, both in members of audience for joining in, and as well as for Jean, for Julia for organizing this, for Evelyn and for Emma for making time to share their insights and knowledge with all of us. Thank you.
So hello and welcome. Thank you for joining. My name is Evelyn Münster and I'm a data visualization designer. What the spot makes errors? How to explain AI to managers? So what is my motivation in life? I tell you a story. When I was young, I was very bad at math in school. Well, I really tried, but it just seemed that I had no talent. So when it came to the final exams, Abitur called in Germany, I was desperately looking for help. So I was strolling around in a bookstore in Munich, and I stumbled upon a book that explained exactly the material that I needed. So I started reading and I got really thrilled because this book explained math so well. I suddenly understood everything clearly. And finally, I got 15 points in the exam, which is the best grade that you can get. And my teacher said, oh, wow, no one ever got this. And well, I was really proud, but I knew by myself that it wasn't completely about me. It was more about the quality of explanations. So this is me trying to figure out math. So as I see it, there's a wall between the noobs and the experts. And the wall has many doors. So the experts trying to build doors in the wall so that the noobs can enter their field of knowledge. But if you're on the noob side, you're trying the handle of all those doors, and most of the doors won't open for you. So you just cannot understand the explanations. So this is also called curse of knowledge, because the experts have difficulties explaining the things that they already know. So with this experience, I decided what I wanted to do in life. I want to build better doors in that wall, doors that actually work. So, but how can you explain complicated things? And I want to show you today a project I did lately. So say hello to Jack the Checker. Jack is a bot and he checks invoices. He can identify whether they are correct or wrong. And this is very important, for example, in the insurance industry. The problem is he is not always right. Sometimes he makes errors. And customers do not want to buy a robot that makes errors. The risk seems like a black box. Of course, they see the opportunity to save a bunch of money, but insurance people usually hate uncalculable risks. So my client used to present lots of complicated data in tables, the confusion matrix, which is really confusing. And in the end, this chart that shows a correlation between the error rate and the volumes of invoices processed, which is even more confusing. So they needed something that explained the bot and the statistical patterns in order to turn the risk into a calculable opportunity. The result is this video that I'd like to show you now. Hope this works.
How Jack the Checker can help you with invoice audit. Are you drowning in a flood of bills and invoices? Many enterprises, like insurance companies for instance, receive stacks of invoices every day. Before these get paid, they need to be checked, of course. But who's going to check all these invoices? Many times, the costs for experts exceed the invoice amount because the work of these professionals is expensive. How can this problem be solved? With Jack the Checker, the intelligent robot. Jack learned to check bills. He's using artificial intelligence to do it. Jack recognizes patterns in the invoice and compares them with the patterns of many other invoices. The more invoices he looks at, the better he learns to distinguish correct from wrong invoices. Jack assigns a correct invoice to the OK stack. A wrong invoice goes to the No stack. If Jack's not so sure, the invoice is placed somewhere in between. When Jack's done, it'll look something like this. To be precise, Jack gives each invoice a score between 0 and 1. 1 for 100% sure the invoice is correct, 0 for 100% sure the invoice is wrong, 0.4 for might be wrong, not sure though. What happens when Jack is done? All probably wrong invoices with a grade below 0.5 will be checked by an expert. All probably correct invoices with a score higher than 0.5 can be paid directly. But wait a minute, there's one more thing. Let's look back at Jack's work again. Just like any human, Jack can be wrong about something. Let's assume Jack has misplaced these invoices during the screening process. That's not a problem for those invoices that are in the No stack but are correct. because the expert will notice the mistake. However, no one will notice those bills that are in the OK stack but are wrong. These bills would get paid even though they are actually incorrect. Looks like a mess. How can we solve this? A little tip: the closer the grade is to 0.5, the more invoices are proportionally sorted wrongly and end up in the incorrect stack. Jack's idea is that not only the wrong invoices, but also some of the correct invoices should be checked by a human being. The volume of these checks, however, depends on your willingness to take risks. Fewer checks mean a higher risk of incorrect invoices being paid in error. More checks reduce this risk, but can get a little expensive. Choose your own risk.
So, I hope you liked it. For my client, this video really changed everything. They got people to understand the inner workings of the bot and the process. And they know how to deal with the risk, and they have trust now. So now my client is finally selling the bot to big insurance companies, which is really great. So, but how does it work? They wanted initially asked me to do a data visualization, but in the end they got an explainer video plus this explorable explanation data risk thingy. So why did I choose this and how did I design it? Everybody's talking about storytelling with data. And to be honest, I'm not even sure what they mean. All I know is that there is no story in the data and no meaning unless you add it to the data. Data is completely void of any story elements that we humans need so badly to understand it and make sense of it. So that's why I added the story that explains the process behind the data. People need to understand the system and the process first, because only then they are able to interpret data correctly. So they need to build their own mental model of it. And another thing is, one thing that I like personally very much about the video is that during the process of sorting those invoices, by throwing the invoices to the ground, the final data visualization, which is a stacked histogram, is being built up. And so I am using the story not only to explain the invoicing process, the invoice checking process, but also to explain this histogram to people that usually cannot read histograms. And a third thing, maybe the most important thing when you start designing with data, is to always start with the goals that you want the user to reach. Do not never ever start with the data. First, get a really detailed picture of the before and after state. Think of every data visualization as a transformation that actually transforms the user from 0 to hero. Only then you are able to create a data visualization that actually nails it and can be and has the intended outcome. And it's not sufficient to just have like one sentence of your goal, like explain the user the bot. That wouldn't work. You have to work through the different levels of meaning, from high level to medium level to the tiny details. The tiny details could be the exact situation where the user is in when he looks at your data visualization, or for example, other people's involved, like stakeholders. Also the concepts they need to grasp. Do they have existing mental models? Are those models incorrect or imprecise? Also other obstacles, for example, low data literacy. Think of the histogram. So this is what I collected in the data design strategy for Check the Checker. So the main goal was trust and user acceptance, and the medium goals were explain the robot output and risk strategy, explain inner workings of the robot, and last but not least, put the user in control of the risk. And we went even down to all the details like data literacy and things like this. I came up with the House of Analytics Jobs. So these are the high-level goals that might be true for your data visualization or data product. Because often data visualizations have goals like these. So to start on the bottom with the foundation, if you know nothing, like we started with the coronavirus when it was new. So the goal of the first visualization were just knowledge generation, create awareness, stimulate discussions. Then it goes up. For example, performance feedback loop. This is classic for dashboards. It goes even up, and on the top you see the actionable insights. So AI-driven often, that give predictive and prescriptive insights, and for extremely for those you really need to build trust first. Yes, okay. So these are some really important design strategies, but there are even more data design strategies that I used to create in this video. I used to create this video and I cannot show you all of them today. But if you're interested to learn more, you can do one thing. Please help me build my online course. Yes, I'm currently creating a course about data visualization specifically for data products. And you can help me making this a success by telling me your vision of a great online course. So I put together this short 5-minute survey to collect your feedback. And you can find the link in a chat. I will soon post it there. So this would really mean the world for me if you could fill this out. And we are already coming to the end. Thank you so much. I'm really looking forward to the questions, and I'm even more looking forward to Emma's talk now.
Thank you so much, Evelyn. Before we move on to the presentation of Emma, I have one question in the Q&A. So one question is, does a bot, aside of an evaluation of correctness, also provide a diagnosis for its judgment?
Yes, exactly. This is what we were seeing in the video with these grades from 0 to 1. So if you have, for example, a grade like 0.6, it doesn't only mean that the bot thinks the invoice is correct, but it also means that he's not really sure about this. So the closer you are to the middle, to 0.5, the more unsure the bot gets. So he's also evaluating the quality of his decisions at the same time. And I think this is the thing that is so difficult to understand. Yeah.
Yeah, that's one of the main challenges.
Yeah.
Thank you.
It took me like 2 days to wrap my head around.
Only 2 days. We have another question from Linda Hartman. Understanding how to read these charts is very important for all kinds of kids in school. Do you know of any initiatives that do these in schools?
Yes, I heard of some initiatives from Italy and also in the US. So maybe I can find out the links and send it to you later. There are some great data visualization books for children, but unfortunately they're all in English. So I cannot give it to my son, but there's one from Australia and some great books out there.
Yeah, it would be lovely if you can share them, maybe in the chat later today, or otherwise we can put them in a news item.
Yes, maybe I have to look this up first. So I write myself a note.
Then we have one more question.
Yes.
From Peter from, does the bot, oh, I already answered that one. Never mind. We have had all questions. And if anyone has other questions, feel free to put them in the Q&A. Emma, do you maybe have another question?
Yes, thank you very much, Evelyn. I really enjoyed everything you said. I couldn't agree more. It's very well said as well. You're a good storyteller. I couldn't do better. I was particularly interested in the reaction of the domain experts who are not technical experts when they saw this video and when they're given a tool to move that threshold. I was wondering if it also motivated them to look a little bit deeper into the technology. Can those storytelling and explanation also motivate people to go one step further? Did you notice that, or are they just enough information and they stop there?
I don't have information on this actually. I only know that the next step would be, and I think this is in your talk more a topic, that you be aware that this is only a sample, a test sample, what you're looking at, and maybe your own invoices, the situation will vary very much. So normally you have a drop down, and you can select different samples and play around. And the first thing that people request is, oh, can we have our own invoices in there, our own data? I want to look at my data, so see where I am. So this, at least I know, yeah.
Great.
Thank you so much. I think we have time for one more question, which has just popped up, which is very exciting. I'm very curious about the bot. Can you share the link of the product? Also, do it use an asymmetric loss function? Does it penalize type 1 errors heavier than type 2 errors?
Well, I don't know because I'm not the data science behind this project, but I can connect you to the company and the data scientists, and they will happily answer your questions.
Yeah, I think that would be lovely.
Yeah,
we will make that happen. Thank you, Emma. Would you like to start your presentation?
Of course. I'll start sharing my screen. I have to warn the audience that I won't be such an amazing storyteller. I'm afraid it's going to look very plain. I'm going to start with a very long title for my presentation. So it's basically about making classification bias more understandable and the bias in the end results, like Evelyn said. And to do that, we need to have the right data before we need to do the data design. I really like that term, Evelyn. And for the data design, we're going to have to do math. And this time we're going to use old math, actually much before AI was ever out in the wild. There was already math applicable to it, of course. But first, oops, apologies. Just a second. First, we're going to start with simple bar charts and explain what I mean with classification bias in this case. So, very simple. Let's first define a classification error. So you're trying to classify objects that belong to a class. Now we see a very simple bar. It represents all the objects you should classify in class A. And now this other bar represents what you have actually classified as class A, and it's not everything. So you miss some objects, and these are your errors. This is the amount of errors. Very simple. So now about bias. There are many definitions. Today I'm very interested in bias in terms of differences in error rates between classes, for instance. So in that case, we can see two classes, asthma and bulimia, A and B. And we can see that for bulimia, there's much more errors than for asthma. And if this was a classification system to detect what is your illness, you will be biased against bulimia patients because they would suffer much higher error rates than others. Then a slight variance of that is when you have differences in error rates, not between classes, but subpopulation. So for instance, here in asthma, maybe for men and women, if we look at them separately, we can see that there is a bit more errors for women. In that case, we can say our classifier is biased against women. So this is the type of bias I want to talk about today. And now we're going to get a little bit one step further, get ready. We're going to talk about variance. So what is variance? It's random variance is when you take several samples. So for instance, several test sets. Usually we have only one, but let's imagine we take another test set and we see what error rates we will get. We will have slight variations. So here in this bar charts, I show 5 different samples, and you can see you have the slight variations of error rates. And then when you analyze the bias, if you start to consider the variance, it makes things a little bit more complicated. You can wonder, okay, what is the maximum bias I can observe in real life? Maybe that's the difference between the both extreme. And then how often does it happen? Is it rare to have this gap? What is the average gap? For instance, here for another class, we can draw the average difference in error rates and see they are quite close. What does it mean? Is it the average bias, and is it a significant bias? Those are questions that are yet, we don't have well-established methodologies to answer. And what I want to talk about today is how to make visualizations to see it, and also how to make the right data to see it. So the first argument I have is that estimating confidence interval is essential to quantify the bias and estimate the risk of occurrence, the probability. Confidence intervals, it's a range of values in which you would say, if I take several samples, a lot of samples, my error rate will fall within that range. So here I can draw a 99% confidence interval, which means that if I take 100 samples, 99 of them, almost all of them, will be in that range. I could have another type of confidence level, let's say 90%, so it's a smaller interval, and now it's only 90% of my test sample that would fall in that range. And finally, even more unusual is a 50% confidence interval. Now it's a little bit more narrow, and it means half of my sample would have an error rate in that range. So I hope you bear with me, because if we calculate those range and the chances that they occur, we have very interesting information to quantify the biases. And we can say things like, okay, I take the average for men, and I look how many women would have an error rate above that. And in that example, we can see, okay, it's 95% of women that have a higher error rate than expected for men. It should be 50%. So here we can quantify the bias in that framework. And variance is very important, because if we had, let's say, a smaller sample for women, the variance would be larger. And now it would be only 70% of women would have a higher error rate. That's why it's essential to look at the variance and not only at the average error rate. But we still need methods to estimate those confidence intervals and to interpret them. Another interpretations we could draw is take the max of the very large confidence interval that would capture almost all the samples. And we can see how many women have a higher error rate. And in that case, just in that example, it's almost half the women that have a higher error rate than ever expected for them. So that's how those confidence intervals can get very interesting to quantify and to visualize these biases. Okay, and now to try to draw them, I just want to introduce you to some of the old math. Don't worry, I won't torture you with too many details. Just a quick overview. So to estimate the variance of one error rate, It depends on the class size and the size of your test. So you took a test set for one class, and what was the class size? And it's very well established in sampling theory, even before Cochrane published a major book in 1970s. And basically, the smaller your sample, the larger your variance. That means that you have only a few examples and you're not so sure what is the range of error rates that you could have in other samples. What gets complicated when you deal with real people, with end users, is that they want to know the number of errors in their data sets, on the data sets on which they apply a classifier, not only on a test set. They're usually dissatisfied, your end users, when you show them a test set and say, oh, I have a low error rate, I think that's okay, and now use this classifier, and they have no idea what's the magnitude of errors to expect in real life. So in the world of computer scientists, a real life data set on which you apply a classifier, it's called a target set. And here I could show you estimates we could have if we had a test set of a certain size. And for a target set, we can guess that the error rate would be the same on average. But if my target set is smaller, the range of value that the error rate could take, could vary more, because it's a small data set. That's basic statistics. And so one thing that you will need to do to estimate those confidence intervals in real life situation is to consider two components of variance. That's the work we did with Linda Hardman. We could show that to do estimates, you have the variance due to the test set size plus the variance due to the size of your target set. And that's almost it for today, but there are much more math that needs to be done on this problem of variance. Your class proportions can change randomly, maybe sometimes a bit more women, sometimes a bit more men. And if you consider these two possible variants, the error rates and the class proportion, that's how the equation would look like roughly. Then your populations, your subpopulations can vary. Maybe at some point you have more people of color, more white people for facial recognition, for instance. Then also the feature distribution can change, which means, for instance, maybe some type of characteristics makes the system make more errors. So there are many other factors to consider. There's more math to do when you want to estimate the errors in the end result. So I just show you an example of the method to apply. I won't torture you with detail. I just want to point that these methods were developed in the 70s first and then continued a bit later. So that's old math again. And worst is to draw the confidence intervals, you would need to use a piece of math that's even older. It's from the 30s. It's from Filler's theorem. And with that, you can have confidence intervals. But I don't want to torture you too much with math. That's it for now. We're going to relax a little bit now with simple bar charts to start discussing how to visualize this variance. So I want to introduce to a bar chart that we developed also with Linda Hardman and Jos van Doorn. It's called Classy. And the basic principle is to use the zero line to separate what is detected and what is discarded. For instance, the good invoice and the bad invoice, or the people with asthma, the people without asthma. So everything above the zero line is what is detected in blue here, and below is what is not detected. So these are your errors. Those are the people with asthma that you didn't detect. One step further is also to check if you have errors for another the class that you should not detect, so people without asthma. And there, what is below the zero line is good. You should not have detected them. What is gray and what is black is also errors. So originally with these simple bars, you could compare both errors in the red bar block and the black block. And you could draw a graph like this on the right. That is the same as an RC curve. It's reusing also the same principle as what Evelyn explained, that you might have a threshold where you have a score indicated how sure or not is your classification. And if you change that threshold, you can adjust the errors. So if you have a very low threshold, you classify everything. That's on the bars you have on the left. And on the right, you start to discard everything. So you see the bars moving down. And somewhere in the middle, you start to have a good trade-off. You can decide, for instance, if you'd have more of the black errors or the red errors. I hope you bear with me. Now that's the last step, because we need to go just one step further, is to show the variance now. So what I propose to do is to show the variance on this principle using the same bar charts on the top and the bottom, because that depends on where a user would like to look. It would be the same range for each big bars. Also, I propose that the most salient element in the visualization is the range of possible value, not the solid bar below. That's to drag the user attention on the variance itself and not drag too much attention on the main bar. That can first clutter the visualization, and also it's been observed and documented in the literature that with a confidence interval that are too narrow, like just simple I forgot the name, so simple bars, people would not look at them very carefully. They would still focus on the average. So that's what I propose to do, and keep the same color coding, and that's how the graph would look like now if you start to adjust the errors. And you could see what is the range of risk that you take for each threshold. And another example where this time I consider two factors of variance, the random variance of error rates and the random variance of class proportions. And you can start to see that those range of possible value are quite large sometimes. And the last point I want to make is that now we see a dashed blue bar. It's meant to represent a requirement. Let's say your requirement is that you must at least have good correct detection, at least at this level. And if you consider the average, you could see one bar where on average it's above the threshold, and that's good. But with the variance, it will be lower that threshold. So my last point is that showing the variance will help you make better balance to handle the risk of bias, and to consider a requirement not with just one absolute value, but consider the requirements also in terms of what are the range of values that you can observe in real life. So I look forward to your questions. I could explain something a little bit more, so please don't hesitate to let me know. Feel free to check the publication or some of the code and write me if the code is not well maintained, please.
Thank you so much, Emma, for your presentation. It was very interesting. It was a good brain cracking thingy. I really enjoyed it. We have one Q&A question that just came in. The question is from Linda. It would be really nice to see the error graphs of Evelyn and Emma side by side, although it doesn't work in our tech environment. Is this something we can realize?
Right now?
No, but maybe in the future. Is it something you think would be interesting?
Yes. I'd like that.
Actually, this is also what I thought. I need to see it side by side. So really interesting graph, this classy thing. Yeah.
And does the code on GitHub also have the interface? So you can do sliders, or is it the code that you have to type in?
So this R code, it's to make the simple bar charts. It's not an interface. The bar charts you could export them in PDF. It's not even interactive. It's not even D3 through R. But we had made an interface where you could upload your data and see different graphs, RC curves, and also the classy visualization and switch between the two. I will add this link in the slides later that you will put online.
Yeah, that would be lovely. Anushtub, do you have any questions perhaps for the speakers?
Yes, I have one particular question. It is less connected to the mathematical part of what Emma described, but more connected to the origin of how did you come to actually spot the need for looking, because what you did, both of you, what you did actually was looking into diving deep into the bias part of data analytics and visualization. So how did you, what triggered the interest into this particular sort of classification problem?
I can start. For me, it was really a push from end users of those systems. It all started at the beginning of my PhD, where we were working with wonderful teams making computer vision that was able to recognize fish underwater, which is extremely difficult. And biologists that want to take care of a wonderful underwater ecosystem with coral reef fish, and that were very keen into exploring new technologies to make a better monitoring of those fish, but still we're scientists. So when you give them a classifier for fish to use for scientific research, besides the enthusiasm and the creativity for experimenting, at some point, if they use it for research, they must know what's the number of errors, what is the variance for those errors, to make proper statistics. So for me, it started with this.
Yeah, I would just like to thank everyone. Also, we're reaching towards the end of the webinar in terms of time, so I would like to just I'd just like to quickly thank everyone for joining in, for taking part, for spending some time with us, and also to our great two panelists. These are very complex topics that you made very, very easy to understand, be it for people who come from a data science background or who work as data scientists, but also people who do not work as data scientists. So these things are real life examples, and this is why it becomes even more interesting, because it is not abstract. It's really gritty. It's really something that happens in our everyday business as data scientists, data analysts, data professionals, data visualization experts, data storytellers. So yeah, thank you everyone for joining in, and thank you to Julia and Jean for organizing this jointly with us, and looking forward to many more.
Thank you to you too, and we enjoyed collaborating, and